Hello guys, this is Gredi here. We are going to prove that the divergence of the curve of vector A is 0. We are going to prove that the divergence of the curve of the vector A is 0. And for your information, this mathematically is written as the divergence of the curve of vector A. And this nabla or del operator, it is also a vector, so you give it the direction. So, as we know, this nabla is the partial derivative of the hand with respect to x, I, plus with respect to y, j, plus this with respect to z, k. And this vector A is having the component on x plus the component on y plus the component on z. And then you have this one. So we are going to first of all compute the curve of this vector A, which is going to be given by have the partial differentiation with respect to x, partial differentiation with respect to y, and the partial differentiation with respect to z. We have component on x, we have the component on y, and we have the component on z. So we have I, and we have derivative with respect to y, and then az, and with respect to y, and as j, I mean plus, and because we put it plus, we are going to start with this one instead of that one. So we're going to put z ax minus then x, then az, we are here, then plus k, partial derivative with respect to x, a1, we are here, with x, then ay, and then we are there, minus derivative with respect to y, then a, and this one is the curve A. So we have this one. This will be equal to, remember we have this one here. So I'm going to dot it with this vector that we have done here. And it's going to be partial differentiation with respect to x. It's going to go with this one of I. The component of I on this side, we're going to put them together. So it will be y and z y. Then plus, we are here on the component of j. It goes with this one also of j. We have partial differentiation. And then here we have differentiation of ax with respect to z minus then plus, we are here, this k, it goes with this one, so the components are going to be multiplied, so we have with respect to z, ay, so this one multiplies inside, so it means it's going to be the double differentiation. It's going to be the double differentiation of this az with respect to x and y minus double differentiation of ay with respect to x, z, plus this multiplies there, we have double differentiation of ax with respect to y and z, then minus this multiplies there, this is double differentiation of az with respect to y and x, then plus, we are here, this is the multiplication of ay with respect to z, x, and multiplies there, minus this one, ax, and z, and y. So this is what we have now. And we want to check if there are some common terms which we can cancel out. As we can see here, we have the double differentiation of az, and here we have the same. And for your information, when you have yx like this, it is the same as having xy. This is the same. Multiplication is completed. So this one has a positive, and this one has minus. So we can cancel them out. These ones. So this one has minus, and this one has positive, so we can also cancel them out. And then we remain with this one which has positive, and then this one has minus. We can also cancel them out. And then finally, we can say that the divergence of the curve of vector A is equal to 0 says this one is equal to 0. Thank you for watching.